So what we're going to see today, contents a solution by LPP by graphical methods. की ग्राफच्या मेथडने कसं LPP चा आपण सोल्युशन फॉर्म करणार. एकदा LPP फॉर्म झाल्यानंतर त्याच्या ज्या टर्म्स अँड कंडिशन्स आहेत त्याला सोल्युशन्स असतात. There are four types of solutions. We are going to see this. What are the types of solutions are there from LPP with the help of graph or with the help of mathematical calculations. The solution by LPP. First one is what do you mean by solution? So solution is a set of values of decision variables which satisfy the constraints of LPP. आपण LPP चे constraint बघितले. Constraints म्हणजे काय आहे? It's a limitations, right? So limitations म्हणजे काय आहे की तुम्ही जेव्हा LPP फॉर्म करता त्याच्या ज्या कंडिशन्स आहेत, त्याला जे रिसोर्सेस आहेत, त्या रिसोर्सेसच्या ज्या लिमिटेशन्स किंवा लिमिटेड माहिती आहे रिसोर्सेसची, त्याच्या बेसिसवर आपण काय करतो? कन्स्ट्रेंट्स फॉर्म करतो. सो कन्स्ट्रेंट्स ऑफ LPP जिथे सॅटिस्फाईड होता त्याला सोल्युशन असं म्हणतात. सो इट्स अ सेट ऑफ व्हॅल्यूज ऑफ डिसिजन व्हेरिएबल्स विच सॅटिस्फाय द कन्स्ट्रेंट्स ऑफ LPP is called as a solution to corresponding LPP. Second आहे feasible solution. Feasible solution, it means a solution which satisfies non-negativity restrictions. आता non-negative restrictions म्हणजे काय? We already seen that for example x is greater than or equal to 0, right? So it's non-negative restrictions. So the solution which satisfies these non-negativity restrictions of LPP is called as a feasible solution. It means the value is more than or greater than 0 or minus. Next one I have third type, it's an optimal solution. Most of the cases में optimal solution विचारता. So optimal solution, it means a feasible solution of LPP which optimizes or optimize म्हणजे काय? When we form the LPP, we define a Z. Right? Z is the main objective or goal of the LPP. So either we maximize the Z or minimize the Z. Maximize केव्हा असतं? When there is a profit area or revenue असेल. Revenue or in case of profit we maximize the goal. आणि minimize केव्हा असतं? When there is a cost. Cost is to be determined for the purpose of calculation. Expenditure on particular family or expenditure of particular product or product line, it is to be minimized. And maximize when there is a benefit, it is to be maximized. So either we have to minimize the goal or maximize the goal. So optimum solution, it means a feasible solution which optimizes. It means which satisfies the objective function is called as the optimal solution of the corresponding LPP. So Z, whatever Z we have formed, it is called as the objective form, objective function, right? When the conditions fulfill with the variables x and y values. These are variables. So when these x and y values satisfy the conditions of Z, objective function, it is called as a optimal solution. Now, next one is convex set. Convex set is for example, region in a xy plane. X and y axis are there, right? It is when we draft the graph by LPP's lines, that time we find a region which lies within the x and y axis. So a region in x and y plane is called as a convex set if the line segment joining any 2 points in the set lies completely within the region. It means whatever the area you have find out with the help of lines drawn in a graph, and the area covered with the graph, and the lines must be lies within the area. It is that set is called as a convex set. So for example, let's check out. So we'll check out whether it's a convex set or not. Now this one. Here we see this lines, right? A and B. It's a line, but it is one point is here within the convex. It's a convex area. The drafted area, it is called as a convex area. One point is lying. A lies in line. B also lies in the convex set, but the line doesn't form or doesn't present a convex area, so it is not a convex set. Now let's see second example here. It's a convex area, right? This one full area, it's your convex area. In the convex area, A and B is a line drafted. It is purely covered in the area of convex, so it's called as a convex set. Next one. Now here, it's a convex area, so here also the line lies properly, both the points and the proper total line, whole line is set in that area, so it's also the convex set. Next is this one. Here, see, A and B points are there in the area, but the line is not in the area. So it is not a convex set. Next one is this one here, right? It's a same area is covered by the lines properly drafted in the area, and both points are also lies in the convex in the region. So it is called as a convex set. The last one here, C. A and B lies in the convex area, but the is not lies within the area. This part is not lies in the convex this area, right? So X and Y pen is not covered by this line. That's why it is not a convex set. So why we are seeing this convex set? Because there may be the sum that they will give you an example lines in a then they will give a graph whether this line is covered by this convex area or not, which convex area is there, whether it is a convex area, whether the line lies within the area, or what are the conditions satisfied by the particular line given to you by the LPP. So for that purpose, we should know the convex area, and the points within the convex area is to be considered for the purpose of calculation of optimal solution of the LPP. So let's check out one example. Now how to plot or draft a convex area on graph. So in on graph, suppose there is a line 4x plus 3y less than or equal to 24. Now remember one thing, when there we draft a graph, it's a x line, right? It's a y. Okay, it's a 0. So if it is a less than or equal to, it means it may be equal to 0. Okay, equal to it means it may be a 0 value, and less than it means 0 ke 0 peksha less than. So when you draft a line, suppose this is a line, the area which is covered including this x and y axis, this area is considered as your convex area. So let's check out this one. And also if it is the greater than or equal to, it means it is not near to 0, it is opposite to 0. So you have to cover the area upward to the lines if it is a greater than or equal to that particular equation. Okay, so it doesn't connect or touch with the 0 values. So this area is not covered if it is greater than or equal to 0, and if it is less than or equal to 0, it means it is near to this 0 value. So let's check out one. There is one sum 4x plus 3y is less than or equal to 24. So how to draft it? First we have to find out the point. So for purpose of point, we make an equation as the 4x plus 3y equal to 24. So there are 2 points x and y. When we write the points in a bracket, it is always the first point is x and second point is y. Remember this. So for the first, if x is 0, okay, then y becomes, right, it's a 0. So y is equal to how much? 3y is equal to 24. So is this 3 becomes divided to 24, and y gets we get a y as a 8 value. So the point becomes 0, 8. And the same, if second point will be, if y is 0, then x is, write this. So 4 is divided to the 24, and you will get x as a 6. So we got a 2 points, that is 0, 8 and 6, 0. So first one is always x value, x axis, and second one is always y axis. So when we draft it on a graph, we'll get the graph as this one. Okay, this is x axis, it's your y axis. Okay, then these are 0. Then these are the points we are going to draft on x axis. Same here on a y axis. So first point is 0, 8. So 0, 8, right? It's a 0 here. X is 0 and y is 8. So the first point is this one. Second is 6, 0. It means y is 6. X is 6, right? It's a x value and it's a y value. Same here, it's a x value, it's a y value. So first is x 0 and y is 8. Second is x 6 and y is 0. So we got a 2 points. When we connect these 2 points, we get a line, this one. This line is called as this line, that is 4x plus 3y. This line, we got this line as 4x plus 3y less than or equal to 24. Now less than or equal to 24, it means we cover this area. So convex area is this is like connected area. It is less than or equal to 0. That's why it is touched to the lines x and y. If it is not given that, it is only given that less than 24, then it will not connect to the x. It is just nearby to the axis. So remember this, if it is equal to greater than less than or equal to, then only it will connect with the x and y axis. If it is not given, it is not connected, then only you have to draft it differently, detached from the x and y axis. Okay, convex area samajhna. Is there any issue regarding this? Because there may be a sum about this property. Okay, is it clear? Everyone gets the idea that x and y axis and how to plot the line on a graph. So let's move for second criteria. Now this one. Again, we will see the next example, that is 8x plus 6y greater than or equal to 24. Now it's a reverse case. It is greater than or equal to 24. So we will convert the line as into equal to. Then we will find out the points at x and y. So if x is 0, y becomes 4. Right? 6 is divided to 24. Uh, then we'll get to 24 as it is. And if y is 0, then x is equal to 3. So we got the 2 points, that is 4, 0, 0, 4 and 3, 0. So when we draft it on a graph, we'll get like this. Is your x-axis. This is your y-axis, right? This is 0. Intersect point is 0. Then these are points. These are points. First point is 0, 4. It means 0, x is 0 and y is 4. So this is your point. And second one is 3, 0. So 3, 0. X is 3, y is 0. When we connect this line, we get the line 8x plus 6y greater than or equal to 24. Now it's a greater than or equal to 24. It means when we find the area, visible area, it will be this one. It connecting to x-axis, this one. So this area covered by this line. It is called as a visible area. Convex area for the line at x plus 6y. It doesn't cover this area. This area will be less than. Okay, and we have the line of a greater than. So greater than, it means the value far away from 0 value. So this one will be your convex area for the purpose of this line. Now we'll see one example of LPP. Suppose there is a LPP given that maximize z is equal to 10x plus 15y. So maximize z is equal to 10x plus 15y is your objective function. So we have to fulfill the objective. Now what are the conditions? Subject to, first condition 4x plus 3y is less than or equal to 24, and second one is 8x plus 6y greater than or equal to 24. X is greater than or equal to 0 and y is also greater than or equal to 0. It means it is more than 0 value, 0 or more than 0 value. So to plot to be plot on the graph, we got 4 points, right? Two lines are there, so we got the 4 points. This is 0, 8, 6, 0 for 4x plus 3y, and second one is 0, 4 and 3, 0 for 8x plus 6y greater than 24. Okay, so we'll just plot out the lines on a graph. This is your x-axis, it's your y-axis, 0. These are your values. So first one is 0, 8, so this is 0, 8. Second one is 6, 0, it means x is 6 and y is 0. This line is 4x plus 3y less than or equal to 24. The second one, 0, 4 and 3, 0. Okay, and the line is 8x plus 6y greater than or equal to 24. Now, in this case, what will be your feasible area? Now, pick out. It is less than, right? Less than म्हणजे हा एरिया कव्हर होणार. ठीक आहे, फर्स्ट लाईनचा. आणि सेकंड लाईनचा काय? दिस वन. सो कॉमन एरिया काय आहे? दिस इज युअर कॉमन एरिया. So this area is called as your visible area or convex area. So this point. This area is your convex area, and we got the 4 points. This 1, 2, 3, and 4. These are your points connecting lies on a visible area. So these points will be tested. So A is equal to, first point we got A is equal to 0.8. Okay. Second one we got B is equal to 0.4. C is equal to 3.0, and D is equal to 6.0. So these 4 points lies on a convex area, because we have find out the convex area as this area, common area for the two lines. So it's a convex area, and on convex area these are 4 points lies A, B, C, D. And we will to calculate or to find out the solution, optimal solution, we have to test the value of Z for these points. So first point is A is equal to 0.8, B is equal to 0.4, C is equal to 3.0, D is equal to 6.0. So for these four values, we find out the value of Z. Z क्या है? Z is equal to 10x plus 15y. What is the objective of this? You have to maximize the Z. So first one at 0.8, it means x is 0 and y is 8. So what it become? 0 multiplied by x is equal to 0 plus 15 multiplied by 8, we get Z value as 120. At the point of 0.4, Z will be 60. Why? X is 0 and 15 multiplied by 4, we got a 60. Then C, 3.0, it means x value is 3, y value is 0. So 10 multiplied by 3, 30, plus 15 by 0, 0. And D, it's a 10 multiplied by 6 plus 15 by 0, it's a 0, so it's a 60. So out of this, what is our objective? Our objective is to maximize. So maximum value is at the point of A. So A will be your ultimate solution, optimal solution for the objective to maximize the Z value. So x will be 0 and value of y will be 8 for the optimal solution for the given LPP. It is called as the optimal solution by graphical methods or by the LPP mathematical methods. ठीक है, क्लियर है? Now we'll see one last example. Suppose there is a LPP given, which we have to find out the graphically. To minimize Z is equal to 50x plus 6y. So we have to minimize the value of Z. Subject to what are the conditions given? 3x plus y greater than or equal to 12, and 4x plus 3y greater than or equal to 24. And x is greater than or equal to 1, and y is greater than or equal to 1. It means the value is not equal to 0. It is greater than or equal to 1. So it's a x and y will be split into one unit value. So let's take out. So there are three lines, right? So we got 6 points. First one, for 3x plus y, we got value of first point. If x is 0, y is 12. Okay, and if y is 0, x becomes 4. So 0, 12 and 4, 0 for first line. For second line, if x is 0, y becomes 8, and if y is 0, x becomes 6. So we got 0, 8 and 6, 0 for 4x plus 3y line. Last one is x is greater than or equal to 0, so x equal to 1, y equal to 1. These are your values for the two lines. So when we draft a graph, so x, suppose this is the x-axis, it's your y-axis. Here 0, these are the values 0 to 12, 1 to 12. Then first point 0, 12. So 0, 12, that is 0 value of x and y is 12. Second is 4, 0. So this is your line 3x plus y greater than or equal to 12. Next one is 0, 8. This is 0, 8 and this is a 6, 0. So we got the value as a 4x plus 3y greater than or equal to 24. Now both lines are greater than or equal to 24. It means we have a area of a convex, it is greater than. So it's always here. Okay, remember this then. Now the next point is x is 1 and y is 1. So x is 1 line is this, and y is 1 line it will be this one. So we did not consider this less than 1. So the feasible area becomes this one, the area which connect all four lines. So this is your convex area. Okay, so the 4 points lies will be this one, and this one. Only 3 points are there. So let's check out these points. So these points will be, when you draft it on a graph, you will get first point as A 19, B 2.4 and 4.8, and C 5.25 and 1. So these 3 points lies in a convex area. So we have to find out the value of Z with these 3 points. So at a point 19, the Z value will be Z. It means we have to insert this value as a X and Y. Just a minute. So this is your X value and this is Y. And we have to put this value in the Z value. So Z is 50X plus 60Y. Okay. So when we put the value of X and Y in a Z, we got a Z as in 590. Here same 2.4, 4.8, Z is equal to 408. And the third one is C. At the value of C, 5.25 and 1, we get the value as a 322.5. So what is our objective? Our objective is to minimize the value of Z. So minimum value out of these 3 points A, B and C is your 322.5. Okay, so this 322.5 is a minimum value. So our solution for LPP is the point C. It means the value of X will be 5.25 and the value of Y will be 1. It is our solution. So value of Z at a point of C, 5.25 and 1 is minimum. And our objective is also to minimize the Z. Therefore, the value of X will be 5.25 and the value of Y will be 1 for the optimal solution for the given LPP. It is called as a solution by LPP method. Okay. So thank you so much. I hope you have got the clear idea about everything about the LPP, how to solve it, and what are the steps to solve the LPP.